So far in this chapter, we've looked at simplifying rational expressions. Today, we're going to look at adding, subtracting rational expressions. Our first problem here is a word problem. It says, in order to produce a picture that is in focus, the distance between the camera lens and the film cube must be controlled so that it satisfies a particular relationship. If the distance from the subject or the person here to the lens is p, and the focal length is f, then the formula listed here can be used to determine the correct distance between the lens and the film. All right, well, they're telling us a couple things in this problem. They're saying 1 over f equals 5/6, 1 and 1 over p equals 1/4. They want us to figure out what 1 over q is. Well, this is a problem we can figure out if we substitute in. So in for 1 over f, we're going to substitute 5/6 minus in for 1 over p, we're going to substitute 1/4. We can find this answer now if we can subtract those fractions. Now recall, we talked about fractions. If you want to add or subtract fractions, we need a common denominator. Well, what is a common denominator between 6 and 4? In order to find that, what we want to find is what is the least common multiple between 6 and 4. So the least common multiple or LCM would be whatever number is the smallest one that both 6 and 4 is a factor of. Well, let's think about 6 and 4. What are the factors of 6 and 4? Let's start with 6. What's the factors of 6? 6, 12, 18, 24, etc. With 4, the least common multiple, or the multiples are 4, 8, 12, 16, and so on. What's the lowest one that we see appear in both? 12 is the least common multiple. So what we want to do now is multiply in order to get a common denominator of 12. In order to do that with the 5/6, we'd want to multiply 6 by 2. And whatever we multiply the bottom by, we'd have to multiply the top by. With 4, to get 12, we'd want to multiply by 3. So we're going to multiply the bottom by 3 and the top by 3. Doing that now, doing the multiplication, 2 times 5 would give us 10 over 12. Multiplying on the other one, we get 3 over 12. Now subtracting those fractions, 10 minus 3 is 7/12. And that's our answer. So when you want to find or add or subtract fractions, the key is to get the common denominator. And usually what we need to do is find the least common multiple. All right, so how do you find the LCM, or least common multiple of polynomials? The least common multiple of polynomials in factored form, keyword being factored, contains each factor the greatest number of times the factor appears. So what we want to look at is how many times does it appear, and we need to use it that many times. Let's look at some examples. Over here, we want to find what's the least common multiple of 6 and 4. We just looked at that. We know the answer came out to be 12. Here's another way you can think about it. Besides listing out all the multiples, you could think what numbers go into both 6 and 4. What numbers make up 6? We know 6 is made up of 2 times 3. What numbers go into 4? 2 and 2. Well, the least common multiple would say we want to do it we want to look at all the factors the greatest number of times. So the least common multiple of 6 and 4 would be 2 2s. Since 4 has 2 2s, we want 2 2s. With 6, 2 appears 1, so we don't need to add another 2, but we do have this common multiple of 3. So if you multiply 2 times 2 times 3, that also gives you 12. That's another way of finding least common multiples. Let's look at the next one. This one's a polynomial now. What's the least common multiple of p minus 3 and p squared plus 6p minus 27? Well, p minus 3, we can't really do anything with this, so that one we're kind of stuck on. But this other one, we can do something with that. When you are doing or working with polynomials, Some steps that you want to do is look at the factor of all polynomials. What does this one look like when we factor it? Well, let's see. We want to think about what multiplies to negative 27 and add to 6. Well, looking at that one, looks like it would be 9 times negative 3. So we want to factor this one. This would factor to p plus 9 and p minus 3. Now we want to multiply each polynomial by the factors it's missing. So what factor is this first one missing? It would need this other term, this p plus 9. So if we multiply it by that, then we would get our common multiple, least common multiple of p minus 3 times p plus 9. We don't need to multiply this second one by anything because it already contains the p minus 3 that the first one has. So the only thing, the second one wasn't missing anything. This first one was missing a p plus 9. So the least common multiple for the second one would be p minus 3 times p plus 9. All right, before we actually go on and try some examples here, we're actually going to go to the back and look at what do you do if you are adding or subtracting rational expressions. Adding and subtracting rational expressions. Just like fractions, to add or subtract rational expressions, you must have common denominator. So that common denominator that you did when you add fractions, you still need that even if you're dealing with polynomials or rational expressions. Let's go back to regular old fractions before we get into some with variables and polynomials. Looking at your first example over here, 2/3 plus 5 or 3/5. We need to, in order to add those, find the common denominator. And common denominator, find the least common multiple. What's the least common multiple of 3 and 5? Well, again, if you list out the factors for 5, we'd have 5, 10, 15, 20. If you look at 3, got 3, 6, 9, 15, 18. Well, you can see our least common multiple would be 15. So we got to multiply by, on the left one by 5 times 5, 5 over 5. On the right, we need to multiply the denominator by 3, so we also have to multiply the top by 3. If we do that multiplication, we end up with 10/15 plus 9/15. And when you add those together, you add the numerators, 19. The denominator is a common denominator, so it stays the same. So the answer would be 19 over 15. All right, let's look at this next one. This next one, now we got some variables. We want to solve it, though, very similar. We got to figure out what is missing in the denominator. So on the bottom of the first one, we see a C. On the bottom of the second one, we see a D. We need a common denominator. So the left one's missing a D, so we want to multiply by D. And if we multiply the bottom by D, we got to multiply the top by D. On the right, we don't have the C, so we got to multiply by the factor of C and also on top by C. All right, so now let's do that multiplication. A times D, AD. On bottom, we have a denominator of CD. Multiplying on the right, B times C is BC. On the bottom, we have a common denominator again of CD. If we add those together, we have the common denominator CD, and on top we have AD plus BC. We can't do anything more with that. That would be the addition of those two terms. All right, let's look at an example here. Let's try one where we have to do some of the adding and subtracting. So number 8, problem right underneath, we want to try to simplify this one. Now you can see we have two denominators here that are not the same. 15y squared, 18xy are not the same. To get a common denominator, we want to figure out what's the least common multiple of those two things. Let's take it piece by piece. Kind of start with the numbers here. 15. 15. What is the factors, or what are the multiples of 15? Well, if we start going through, we got 15, 30, 45, 60, 75, 90, 105. Let's see about 18. What are multiples of 18? 18, 36. We got, oh, oops, sorry, 54. Adding another 18 to that, we got 72. Adding another 18, we got 90. Adding another one, we got 108. Well, you can see what's our least common multiple? 90. 90 is the least common multiple. So now we got to figure out what do we have to multiply by to get 90. So on the right, 15 times what equals 90? Or another way you can do that on your calculator is to take 90 divided by 15. And that should tell us what it is. So if we go on our calculator and go 90 divided by 15, it looks like 6 is the number we're going to have to multiply by. So on this side, we're going to take the bottom by 6, and whatever we multiply the bottom by, we got to multiply the top by. Let's see 18. 18 times what equals 90? So let's do 90 divided by 18. And we see we need to multiply the right term by 5. And whatever, again, we multiply the bottom by, we got to multiply the top by. Okay, next, let's turn our attention to the variables. Variables, in the left one, we have y squared. On the right, we only have a single y. We need the same amount. So it looks like the one on the right, we need an additional y. So we got to multiply by another y. Any other variables? Well, not in the first term. If we go to the second term, we've taken care of our number, we've taken care of the y's, but there's an x. We don't have the x over in the left denominator. So we got to multiply by an x. And again, whatever you multiply the denominator by, you got to multiply the numerator by. If we do this multiplication now, we should be able to get a common denominator. So now we're going to multiply through. If we multiply these, 6 times 15 is 90. That's what we've already figured out. We have an x and a y squared. With our second term, if we do the multiplication, we should get the same thing. 18 times 5 is 90. X, y times y is y squared. All right, now we also have to do the multiplication in the numerators. So we have to take 6x times 7x on the left. 6 times 7 is 42. X times x, x squared. On the right, only the number 5, y times y would be y squared. To get our answer now, we want to combine this together into a common denominator of 90xy squared. The numerators, you add them together. And since they're not like terms, we just list them out separately. 42x squared plus 5y squared. There's nothing else we can do with that one. That would be our answer. Let's try one more here. On this next one, we are subtracting. We're subtracting. So we want to do the same thing. Adding, subtracting, doesn't matter. You have to get a common denominator. So let's look at this one. Common denominator. We need a multiple of 7 and 9. If you list out the numbers for 7 and 9, I don't think we're going to find anything until we actually get to what 7 times 9 equals, which is 63. So on the right side, we got to multiply by 7 and 7. On the right, we need to multiply by 9 over 9. Okay, let's look at our variables. On the left, we have one single b. On the right, we have b squared. Looks like we need an additional b on the left. Looking at the right side, we have an a. We don't have that on the left, so it looks like this other side also needs an a and another a. Now we should get a common denominator, so let's do our multiplication. If we multiply, we got 56 a squared b on the top. On the bottom, we got our common denominator of 63 ab squared minus. On the right, if we multiply 9 times 1, we get 9. And then we get our common denominator of ab squared. We'll finish the rest in class. You can try to finish this one. We'll finish the rest.